Okay, number one, you're finding the GCF of each pair of integers. GCF stands for greatest common factor. And you have three methods you can do. You got t-chart, prime factorization, which is using a factor tree, and then making a Venn diagram. All right. Now we're actually going to skip the Venn diagram because before you can use that, you're using prime factorization. So really there's no point to using the Venn diagram. All right, so we're going to go ahead and do these three questions. Questions 1A, 1C, and 1F. All right, so I'm going to use the t-chart. The t-chart is just listing out all the factors. So really, if you just go and do this, you don't really need the t-chart. Now the t-chart is useful because it organizes or reorganizes the factors in a way where you can check with itself, because it gets a lot harder when you're just listing the factors in order, and it's easier when you're thinking in terms of what number multiplied by what number will give me 12. Right, so 1 times 12, 2 times 6, and then 3 times 4. And then now I know I can stop, because if I go to the next number, 4 times 3, I already have that. So I will just be going backwards. Okay, so this is, if you see, we have all 1, 2, 3, 4, 6, 12. We have all the factors we came up earlier, except in this case, it's organized by pairs, and it's a lot easier to check if we miss some or not, right? So I'm going to make a t-chart for 10 also. Okay, we got 1 times 10, 2 times 5, right? And then 3, 4, there's no factors there, and then I'm done. Okay, the only downside to this is you're listing the factors side by side instead of in order. I mean, if you're trying to read it in order, you're going to be reading it like a U shape. Okay, you can always rewrite it out. If I want to rewrite these in order, I can always just take an extra 3 seconds and write it out, and that's fine too. Okay, but once you list out all the factors, now you're just trying to find the greatest common one. Okay, so they both have 1, they both have 2, right? 3, no, 4, 6, 12, right? So then 2 is the greatest common factor. Okay, and the circling, you don't have to do that, but that's just a way to help me. It helps me keep track of, or I already checked. 1 is similar, sorry, not similar. 1 is the same, 2 is the same, and then I know the last one I circle would be the answer. Okay, so that's method 1. Method 2 is using prime factorization. Okay, now that depending on the numbers, one may be more efficient than the other. Right, making a t-chart, it's not a big deal if the numbers are small. Okay, so with this one, you can still make a t-chart. Right, prime factorization or using the factor tree becomes more efficient when the numbers get bigger. Right, so you'll see in a second over here, it would save a lot of time. Okay, but over here, I'm going to use it anyway. Right, there's really no downside of using a factor tree. Right, so 15 factors out to 3 times 5, right? And then 3 and 5 are both prime numbers, so then I can't go any further. Right, 22 factors out to 2 times 11. 2 and 11 are prime numbers, I can't go any further, and then I'm done. So these are all the prime factors of the respective numbers. Right, and now I'm just going to see if they have any ones in common. And it looks like they don't, which means the only common factor that they share is the number 1. All right, now remember, 1 is not listed if you use the factor tree, because the factor tree is, the purpose of the factor tree is to get you the prime factors. You remember, 1 is not a prime number, but 1 is a factor, or it can be a factor. Actually, by definition, it is a factor of every number there is, because you can always multiply that number by 1 in itself. Okay, so if they don't have any common factors, by default 1 would be the greatest common factor. Okay, All right, last one. This one, you'll be able to see the usefulness of the factor tree a little better. Okay, so I just go ahead and factor these out. If it's an even number, it's always divisible by 2. Right, so I always start with that. Into 11, right, and I'm done there. Okay, 84, I can factor out to 42, 2, and then 21, and 21 can be factored to 3 and 7. Okay, now I look for any common factors. So they share a 2, they share another 2, and then that's it. Okay, now here is where the students sometimes forget what they're supposed to do. They share 2 pairs of 2s, right? Whatever numbers that they share, you multiply them, and that will give you the greatest common factor. All right, GCF equals 4. Okay, so for example, if I'm not going to work out a whole new problem, but let's say one number has 2, 2, 5, 7 as its prime factors, and another number has 2, 5, 11, 11. Okay, again, I'm just making this up. The common ones they have are 2 and then 5, so then you would multiply 2 times 5 equals 10, and then 10 will be your greatest common factor. Okay, and they have multiple pairs, then you still need to take into account. It's not just, oh, since it's the same number, I'm only counting it once. No, if there are 3 pairs of 2s in common, then you would have to multiply 2 by itself 3 times. Okay, so that's the other method. The third method is the Venn diagram. Now, that's just another way of organizing the numbers. So I will still have to do this step. Once I get these numbers, I'm just looking for the common ones, and then I'm putting the common ones in the middle, because that's where both circles meet, right? This circle is for 44, this circle is for 84. Oops, sorry, you can actually see now. All right, and then the factors that they don't share only stay in the circle for 44. So you see 44 has the factor 22, 11, 2, and 2, right? Oops, sorry. 11, 2, and 2, 11, 2, 2, right? 84 has the factors 2, 2, 3, 7, so 2, 2, 3, 7. Okay, so this is just visually shows you that these two are in common, and then you go ahead and multiply the ones they have in common. Right, but as you can see, we can do that step by just circling, okay? And as long as that's not confusing to you, you don't really need to do the Venn diagram. Right, now this is useful for people who are more visual and like to see things separate a little bit, then you can go ahead and do this extra step. All right, whatever works for you, I would do that. But just know that by making the Venn diagram, you still need to do this factor tree step. It's not like you pick this step, you don't have to do this anymore. Okay. Now the table you don't have to do if you use the factor tree, and you can always go back to the table. All right, but over here, if you see, if we use the table, numbers might get, usually the bigger the number, the more factors it has. All right, so as it has more factors, the table becomes harder to keep track, or it takes longer to come up with it. Okay, number 2, I'll let you read that. Number 2 is right here. You can go and pause the video if you need to take a moment to read the question. All right, but John has 3 different types of jam, right? He's got 12 jars of strawberry jam, 16 jars of grape jam, and then 24 jars of pineapple jam, right? And he wants to place each jar, or maybe multiple jars, into a box. Now the condition is each box needs to contain the same number of jars of each kind of jam. Okay, and then he wants to maximize the number of boxes that are possible. Okay, which means, so this question is hard because, well, I want to say it's hard. It may be hard for some students because they have no idea, even though after reading the question, they don't know what the question's asking. All right, so this is where you kind of have to maybe read separate parts of the question to kind of get the better idea. Okay, so again, we know we want to put the jars into the boxes, but we want to see what are the restrictions. Okay, we need to, the combination needs to give you the greatest possible number of boxes. All right, so that means, the less jars in each box, the better. Okay, but then the second condition is each box has the same number of jars of each kind of jam. All right, so not the same number of jars as each other, but as itself. So if I have 4 jars in one box, I need 4 jars of strawberry in one box. The other box also needs to have 4 jars of strawberry. All right, so think of it as you are dividing these boxes into giving it to your friends. You want to keep it fair, so they all need to get the same amount. All right, but going back to the first condition, all right, greatest possible number of boxes, that's probably where you want to start, because the keyword greatest, right, that's what we've been doing this lesson, is finding the greatest common factor. Okay, and when you think about, right now, let's keep the problem simple, is we're just trying to box up 12 jars of strawberry. Okay, if you split 12 into factors, let's say 3 times 4, you can see that as, okay, there's 3 boxes, each box has 4 jars, and that'll make up 12. Right, so if we just have, again, right now we just have strawberry. If we want to put them into the greatest possible number of boxes, then we want each box to just have 1, because that will give us 12. That would be the greatest factor, if we're just talking about 12. Okay, now, question is not that simple, because we are talking about 16 and also 24. Okay, but that is no different than the question up here, where we're trying to find the greatest common factor. So we're basically just trying to find the greatest common factor of 12, 16, and 24. Okay, so we're going to go ahead over here. These numbers are pretty manageable, so I'm just going to use the T-chart, right, where I'm going to list out all the factors. Okay, now 1 times 12, 2 times 6, 3 times 4. Okay, 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, and then I can stop there. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then that's it. Okay, so I'm basically looking through all these numbers, and you probably want to start on the right hand side, because the right hand will go from greatest to lowest, and then you can loop back around. I'm looking to see if they have any common factors. Okay, so 12, this one doesn't have it, so I can move to the next one. 6 does not have a 6. All right, 4 has a 4, and this one has a 4, so that would be my greatest common factor. All right, and that would actually be my answer for boxes. Okay, now, yes, each of these, if you just put one of each, you would get 12 boxes, 16 boxes, and 24 boxes. But remember, we need to divide each kind up evenly. So if I made 12 boxes, that will not be possible for the grape jam, which has 16 jars. Okay, so that's why we're finding all the possible combinations, and then we can find the greatest factor there. Okay, now that's only one part of the question. The second part, it will also want us to find out, actually it doesn't, nope, just wants to find out how many boxes does he need. All right, so 4 boxes, that's our answer. Okay, and if you want, I'll do the factor tree method. All right, 12, 16, 24. All right, and that's 2, 6, 2, and then 3. We got 2, 8, 2, 4, and 2, 2. Right, and this one I'm gonna do a little differently, just to show you, you don't always have to divide it by 2 just because it's an even number. If you're able to see that, you know, especially using your times table, that there is 2 numbers multiplied will give me 24, that sometimes make it easier, because then you split into 2, you know, not so big, not so small numbers, and then they in turn will be able to split into smaller numbers. Right? By dividing by 2, you're always going to split into 2, which is a really small number, and then you're still going to get a big number. Right? But usually, if you can divide this number, that number is going to be smaller. It could still stay big, but it's going to be smaller than that. So logically, you should be able to divide that by factors if you can handle dividing the bigger one. Right? Anyways, we're going to go ahead and see if they have any common factors. So it looks like they all have a 2, and they all have another 2. Okay, 3 does not have a 3, and I don't need to check the rest because if they have something in common, this one's out of factor, so it's done. Okay, so they have 2 pairs of 2's in common. That'll give me 4, and that'll give me the same answer. Okay, number 3. Go ahead and pause the video if you need more time to read it. Number 3 is pretty much the same question as 2. Right now we're talking about different types of candy. So we got 24 lollipops, 12 candy bars, and 42 pieces of gum. Okay, and Sarah wants to put them into bags. Right, probably give it to her friends at her birthday party. Now each bag needs to have the same number of each kind of candy so we can keep it fair. Now, what is the greatest number of bags she can make if all the candy is used? All right, now there's a second part to this question. We also need to find out how many pieces of each kind of candy will be in each bag. All right, but first we need to find out how many bags can be made. All right, so we're trying to find, again, the common factor. All right, and I'm going to use since 42 is a pretty big number, I'm going to use the factor tree. Okay, so 24, I can always divide that by 2. Alright, 12, and anytime you see numbers that you already seen before, you can always just copy it down, or it might be a good idea just do it again. That way you can maybe, if you made a mistake over here, you could find it by working it out again. Alright, 2, 21, 3, and then 7. Okay, so now I gotta look through all the prime factors and see which ones they have in common. They all have a 2. Right? Do they have another 2? Yes. No. Okay, so don't need to check the rest of the 2's. The only one left is a 3. 3, 3, 3. Okay, and then I can stop here, even though 42 has one more factor because this one's already out. Alright, so 2 and a 3, 2 times 3 is 6. Alright, so 6 bags is the answer. Okay, and now the second part, I need to find out how many candy are in each bag. So 24, if I divide that by 6, that'll give me 4. Okay, and then 24 is the lollipop, so we got 4 lollipops. Okay, 12 divided by 6 means each bag will have 2, and 12 is the candy bars. Oops. 2 candy bars, and then 42 divided by 6 is 7. That's 7 pieces of gum. Alright, that's your answer. Okay, number 5. Which of the following is the greatest common factor of 9, 27, and 36? Alright, so we already done this before. We just want to find the greatest common using either the T-chart, factor tree, find out which of the factors they have in common. Alright, so if you use the factor tree, I'm not actually going to work this out. Right, you should be able to do this, and if you can't, you can always refer back to the 2 word problems we just did. It's pretty much the same thing, except it should be easier because they already told you straight up you want to find the greatest common factor of those 3 numbers. You don't have to dig through the problem. Okay, so this is 3 times 3, and go ahead and complete the factor tree for the other 2 numbers, and then find which ones they have in common. And remember, if they have multiple ones in common, you need to multiply them to get the final answer. Alright, number 9. We are given a fraction, and we're supposed to find 3 equivalent fractions. Okay, now that means you can either reduce or expand on a fraction. Expanding is probably going to be the easiest route. Okay, so starting with 9a, we have 8 over 10. Okay, and this is kind of an open-ended question because there are infinite number of possibilities, because you simply just have to multiply the numerator and the denominator by the same number, right? And usually the easiest choices are 2, because then 8 times 2 gives me 16, 10 times 2 is 20, so there's 1 already. Okay, another easy number to multiply by is 10. Right, because that's simply, we just add a 0 to the end, and there's a second one. Right, and you can use any number you want to. Right, you want to do 16, you can do 16, but obviously you want to keep it easy to work with. I mean, you don't have to, but that will probably be the logical thing to do, is to use easy to use numbers. So then this one would be 1, 2, 8. Okay. But as you can see, you can multiply by 2, 3, 4, 5, 6, 7. But to make it efficient, if they want 3, 2, 10, and then maybe 5 or 3 would be the next logical choice. Okay. Number 10. This one's slightly different. We're given a fraction again, right? So there's our fraction. But now it wants us to find a common factor, meaning we are reducing a fraction. Okay, so expanding is easy because we get to choose what the factor is going to be. Now we are more limited. In which factors are possible depending on the numerator and the denominator. All right. So this is going to go back to questions earlier where you're just finding a common factor. Right. It doesn't have to be the greatest, but they just need to have a common factor, and they can both reduce by that factor. Okay. So 10a is 24 over 30. That's an easy one because as long as both numbers are even, they are divisible by 2. All right, 24 divided by 2 is 12, 30 divided by 2 is 15, and there's an answer. Okay, now there are multiple answers to this. Well, some have multiple, most have multiple answers, right? Because we can also, if we keep on going, 24 and 30 also share the factor 6, right? So then if we divide it by 6, let's go and just work it out here. We get 4 over 5. Okay, so both of these are equivalent to each other, so they're both correct answers. Right? Now, over here, you can't really use that shortcut in observation because one is even, one is odd. That means 2 is not divisible. Okay, now this is where divisibility rules can come in handy. All right, if you want to do it a little quicker or a little more efficiently. If not, the safest way to do it would be to list out all the factors. Right? Just like earlier, if we want to find a common factor, the logical thing to do is to either use a T chart or use the factor tree and see what common factors they have. All right, so 1 times 14 will give me 14, then 2 times 7, and then that's it for 14. Right, 21, I got 1 times 21. 3 times 7, and then that's it for 21. Alright, so it looks like we have 1 and 7 as common factors. Okay, dividing by 1 won't do us any good because it will just be 14 over 21 again. So then we divide by 7. Okay, and that'll give us 2 over 3. Alright, and so in this case, there's only one possible answer that you can reduce to, whereas over here you have multiple. Okay, so it just kind of depends on how many common factors they have. Right, and again, the simplest way, the more straightforward way, is just to find out all the factors and then find out what the common ones are. Okay, and number 11. Okay, this one's taking a step further. Okay, it wants us to find the greatest common factor. Right, use the GCF. And anytime you find the greatest common factor and you reduce the fraction using that factor, that's also called simplifying to the simplest form, right? Meaning you cannot reduce it any further. Now there are some numbers where if they don't have If 1 is the greatest common factor, then that means it's already in its simplest form, and that would be your explanation. If you do find a problem where it can't reduce anymore, that would be your reasoning, because the greatest common factor is 1, it cannot reduce anymore, right? It's already in its simplest form. So 11, we got a pretty big number, 108 divided by 160, okay? I would probably suggest using the factor tree method instead of the T chart over here, because potentially you could have a long list of factors, right? So that could take some time. So by using the factor tree, I could potentially save time. All right, so 108, the obvious one would be 2, right? And then I'll have 54 over here. Okay, and then I can divide by 2 again because it's an even number. I'm left with 27, and then 27 can be split into 3 and 9, and then 9 can be split into 3 times 3. Okay, and then I'm done because all of these are prime. That means I cannot go any further. Okay, 160. All right, you can divide it by 2, but I'm going to go ahead to bounce it out a little bit. I'm going to actually divide it by 10. Because anytime I see a 0, I know the number is divisible by 10, right? That will allow me to do 2 and 5 over here, and over here I can do 4 and 4, right? And again, for this number, there are multiple ways you can do your factor tree. So over here, 16, you can split it into 2 times 8 if you want to, okay? So it's just up to you. Now we find out how many prime factors they have in common. Right, 3, they don't have any 3's, they don't have any 2, so then 2 times 2 equals 4. 4 is the GCF, so if you want to label it, GCF equals 4. Okay, now that's not the answer, because the answer wants us to use the GCF and reduce the fraction given to us. So if you divide both by 4, right, you would reduce it. Now, if this is not obvious to you, then you would need to, on the side, use long division. Alright, so then we get 8, 2, 8, and 7. Okay, so that equals 27. Right, and the bottom will equal to 40. And that would be the same, it's an equivalent fraction, but it would be in the simplest form, meaning you cannot reduce that any further. Right, you can even confirm it by using these two numbers, find out its factors, and you would see that they won't have any common factors other than 1, right? So they cannot reduce it any further. Okay, so 9, 10, 11 are closely related, right? 9, you are actually expanding, right? But 10 and 11 you're reducing, but 11 takes it a little further by reducing it to the simplest form, right? Most numbers you can reduce it multiple times, right? And by reducing it to the simplest form, there's only one possibility. So 11, there's only one correct answer. 10, there could potentially be multiple correct answers. As long as they are reducing by the same factor, that should be correct, all right? Number 14, I'll give you a moment to read the question. Pause the video if you need more time. All right, but we are basically writing 40 minutes using fractions. Okay, so instead of saying 40 minutes, we are writing that expressing 40 minutes in hours. Okay, so what fraction of an hour did each practice? So 40 minutes in hours would be 40 over 60. 60 because there are 60 minutes in 1 hour. Okay, so that is for Jeremy. Amy had 45 minutes, and it's also over 60. Okay, and then it wants us to simplify it. All right, so we are to find the common factor, not just the common factor, but the greatest common factor. Right now, I know it does not say simplify to the simplest form, but anytime in a word problem it says simplify each fraction, it is common to simplify to the simplest form, even if it doesn't say it. Right? Always assume the question wants you to simplify to the simplest form. Okay, so coming back over here, right, the safest thing to do is to list all the factors and find out what the GCF is and then reduce by that amount. right? But hopefully the student will be able to recognize using their divisibility rules that, right, 40 and 60, they both end in 0. That means they're both divisible by 10, right? And then if we do that, we can save some time, and then we get 4/6, okay? Now, because we did not confirm that this is a GCF, you would need to check your new fraction again to make sure that that is indeed the simplest form. Now, they're both even. That means we can still reduce by a factor of 2. Now, I'm going to write it down here since I'm running out of room, and that will give me 2/3, okay? Now, again, if that is not something they're comfortable doing, then go ahead and list out all possible factors, right? And usually, factor tree is a good way of doing that. 4 and 10, 4, 2, 2, 2, 5. Over here we got 6 and 10, 2, 3, 2, 5. Okay, and they both share a 2, another 2, and a 5. Okay, 2 times 2 times 5 is 4 times 5, which is 20. All right, and if we go back here, if we divide both the top and the bottom by 20, we would get 2/3. Okay, so 2/3 hours. Oops. That's part of the answer. 2/3 hours is how long Jeremy practiced. Right? And then we do the same for Amy. You would get a new fraction, and then that would be there. Again, you can use your divisibility rule. Like right now, I should be able to tell right away both are divisible by 5, right? But then it's possible that you need to keep on going, so it may be worth it just to take the extra time, find out what all the factors are, right? Using a factor tree or using a T-chart, and then divide both by that factor. Okay? All right, number 15. All right, pause the video if you need a little more time to read the question. Okay, so there are 12 boys and 18 girls, right? And there are multiple questions it's asking. It's asking what fraction of the class is male, what fraction of the class is female, and then simplify each fraction. Okay, so there are 12 boys and 18 girls. Okay, so total there are 30. Okay, and to find out what fraction are boys, you would need to put 12/30, and then there are 18/30 girls. And the last step is to simplify both. And again, always assume they want you to simplify to the simplest form. Okay, so following becomes the same question as 14. Find out what factor they can simplify by, and then go from there. All right, you can find like GCF, and then that would be you only have to reduce it by 1. If you're gonna go one at a time, then you have to keep checking. Okay, in this case, if they're more comfortable, they can just divide both the numerator and denominator by 2 and keep going until you have to find another factor. But again, sometimes they'll be faster, sometimes not. The best way is still to just find the factors and then divide by them. All right.